Find the gradient of a line, you need 2 points on that line. So I'm just going to identify 2 points on this line. My first point here, x equals 1, y equals 2. I'm going to write down my first coordinate, x1, y1, as x equals 1, y equals 2. My second coordinate I'm going to choose here is this one just here, where x equals 2 and y equals 4. So my second coordinate here, x2, y2, is x equals 2, y equals 4. Now to find the gradient of this line, I just need to do the difference in the y values, that is 4 minus 2, and divide that by the difference in the x values, that is 2 minus 1. So here the gradient is going to be 2 divided by 1, which equals 2. So the reason that I've wrote out our coordinates like this here is so you can see what the general equation is for the gradient of a line given 2 points. So if we want to find the gradient of a line M, it's going to be the difference in y, so one y coordinate take away the other, divided by the difference in x, so one x coordinate take away the other. So you see here I've kept my y coordinates and my x coordinates in the same order. I've done y2, we read this as minus y1 over x2 minus x1. Now we could actually do this the other way around, but the order is important. You've got to be consistent with it. So I could say that this is equal to y1 minus y2 over x1 minus x2. And if we try that with our example, if we do this the other way around, we could say top is 2 minus 4, which is minus 2, divided by 1 minus 2, which is minus 1, and minus 2 divided by minus 1 gives us 2. Okay, if I was given a question like this, if I was asked to find the equation of a line that passes through a specific point here, 1, 3, and has gradient 4. Drawn a little sketch of this. Here's my specific point. We know it passes through 1, 3. I've also put on a general point, any x and any y. And we know from our definition of the gradient that the gradient is going to be equal to m is equal to the difference in y. So this is going to be y minus 1 over the difference in x minus 3. But here we're told that the gradient is actually equal to 4. So we end up getting the equation y minus 1 over x minus 3 is equal to 4. And we can manipulate this to find the equation of this line in several different forms. One form that you will recognise from GCSE is y equals mx plus c form. Here m again is our gradient, and c is the y-intercept, where this line actually crosses the y-axis, the x value of that. So let's rearrange this into that form. We've got y minus 1 over x minus 3 equals 4. So that is y minus 1 equals 4x minus 3. So we've got y minus 1 equals 4x minus 12. If we take the 1 to the other side, we get y equals 4x minus 11. So we found the gradient, the equation of our line in the form y equals mx plus c. Now we can generalize this. If we're given a coordinate, a specific point that the line passes through, x1, y1, and we're given the gradient of the line m, then we can construct this equational formula that is going to tell us how to find the equation of that line. So remember, m is equal to the change in y, so y minus y1, over the change in x minus x1. And this is actually our construction formula here, but a good way of remembering this is to multiply both sides by x minus x1. So we get m times x minus x1 equals y minus y1. So if we're given the gradient of a line and a point it passes through, we can just plug that in to this formula here. We can plug in our gradient here and our x coordinate here and our y coordinate here, and then rearrange that to get the equation of the line in any form that we want. Okay, so if you're given two specific points, x1, y1 and x2, y2, and you want to find the equation of the line, you can do that in one step without finding the gradient first. So we've got our two specific points and we've got a general point here. And what you should remember, the gradient of a straight line, it's going to be constant. It's going to be the same no matter if you evaluate it between our two specific points or between our first specific point and a general point. We're going to get the same value. So if I evaluate the gradient from our two specific points, it's the change in y, so y2 minus y1 over x2 minus x1. And that is going to be the same as evaluating it from our first specific point x1, y1 and a general point xy. If we do that, it's going to be y minus y1, the change in y, over x minus x1. So I just want to point out here, it can get a bit confusing with the notation. This is a specific y coordinate. This is also a specific y coordinate. The same with our x coordinates here. This is a general y coordinate. So we're just going to leave this as y, and this is going to be the y in our equation. And again, this y1 and this x1 here, they're specific as well. Now we can rearrange this equation a little bit. We can multiply both sides of the equation by this x minus x1, and also divide both sides of this equation by this y2 minus y1. And if we do that, we're going to end up with x minus x1 over x2 minus x1 is equal to y minus y1 over y2 minus y1. So if you remember this formula here, all you need to do, given 2 points, is plug in these points into this equation, into this formula, and you'll have the equation of a line. Okay, so you should remember this from GCSE when we're dealing with parallel lines. So here I've got two lines. My first line I've called L1, my second line L2. All you need to remember about parallel lines, it should be quite evident, is that they have the same gradient. So if the gradient of L1 is M1, that is going to be equal to the gradient of L2, which I'm going to call M2. The thing that you need to remember is perpendicular lines. Here we've got two lines that are perpendicular. They make a right angle where they cross each other. So I've called my first line L1 and my second line L2. Now, a result about the gradients of lines which are perpendicular is that the product of the gradients, so let's say the line L1 has gradient M1 and the line L2 has gradient M2, and this is our product of the gradients, M1 times M2, that is going to be equal to -1. So what this means is if you've got the gradient of a line and you want to find the gradient of a line which is perpendicular to that one, you can use this result here. But you're probably going to need to put this into another form. You're going to say M1 is -1 over M2. So a perpendicular gradient would be the negative reciprocal of a gradient that is perpendicular to. Okay, so here we've got an equation of a straight line, 4x plus 3y minus 1 equals 0. And I'm not sure if you would have seen the equation of a straight line in this form before. This is another form that we use at A level. It's the form ax plus by plus c equals 0, where a, b, and c are all integers, they're all whole numbers. And he's sometimes asked to find the equation of the line and give your answer in this form. But say we were given a line with this equation and we wanted to find its gradient. What we need to do is rearrange this so it is in slope-intercept form, the form y equals mx plus c. Because then, just by looking at this coefficient of x, we can find the gradient of this line. So let's just rearrange this line quickly. We've got 4x plus 3y minus 1 equals 0. So I'm going to take away 4x from both sides. I get 3y minus 1 equals negative 4x. Adding 1 to both sides, I get 3y equals negative 4x plus 1. And dividing by 3, I get y equals negative 4 over 3x plus 1 over 3. So now I've found the gradient of this line. The gradient is the coefficient of x. It is minus 4 over 3.